So combination of pulleys. Okay, now we discuss combination of pulleys. Okay, there are two types of combination. One combination here, one pulley is fixed, one pulley is fixed, other is movable, and second type of combination is block and tackle system. Block and tackle system. So first we discuss one pulley is fixed and other is movable. Okay. So first type of discussion here is one pulley is fixed, other is movable. Okay. First we try to draw a diagram. Okay. So here is a rigid support here. That is a fixed or rigid support. Okay. Here. So that is a one pulley is fixed. So we'll draw that a fixed pulley first. That a fixed pulley. That is axle. Okay. And there's a movable pulley here. Okay. So that is a first movable pulley. Okay. That is a second movable pulley. Okay. That is drawing neat and clean. Okay. The second pulley, that is a third, four. That is a four movable pulley. Okay. Now, okay. Now, there is a connected to rope here. So first that rope first rope. Okay, first rope. Now that is a second rope. Another color here put, that is a second rope. Passes from that pulley axle of that pulley. Now that is a third rope. Now the fourth and final. Okay, rope is connected. The fourth. Okay, so now the load is hanging here. Load from here. That is a load. Here. Clear? Okay. Now, so some person here to apply a effort. Okay. So here we see that is a red color pulley is a fixed pulley. Okay. That is a fixed pulley, and that is a 1, 2, 3, 4. That's 4 pulley are movable. That's 4 pulley are. That's all 4 are movable. These 4 are movable. Okay. So first, now draw, analysis the diagram. First, if a load goes downward, that is a 2 tension here. Okay. Suppose we put a T1 and that is give a T1. So one rope, same rope is same tension. Okay. So same rope is the same tension. That is the key point. Same rope is same tension. So T1, and here the yellow color rope, that is a T2 tension. Tension is different rope. That is a pink color, that is a T3 tension, that is also T3, and as a gray color, that is a T4, that's also tension T4. Okay, so and that is also T4 tension. Now the direction, that is upward, that's also upward, that also upward, that also upward, that also upward, that also upward. Here the T4 also in that direction. Why? Because the effort is applied in that direction. Okay, now we apply Newton third law. First we Newton third law apply in movable section. Apply Newton third law. Apply Newton third law in movable section. Okay, here that load, first this load is balanced here. So here L, that is equal to 2T1. Okay, and here the T1 also balanced by 2T2. T1 also balanced by 2T2, and here T2 also balanced by 2T3, and T3 also balanced by 2T4, and here T4 also equal to effort, and here T4 also equal to effort. Okay, now I replace that. 2T1 equal to 2 into T1 equal to 2T2, and T2 also equal to 2T3, 2 into 2 into 2T3, and 2T3 also replace T3 also replaced by 2T4. So 1, 2, 3, 2 and 2T4. So T3 replaced by 2T4, T2 replaced by 2T3 and T1 replaced by 2T2. Okay. So finally see that is 2, 2, 2, 2, 2 to the power 4 T4, that is also equal to load, and effort equal to only T4. So that is a mechanical advantage. So mechanical advantage is load by effort. That is the load is 2 to the power 4 T4 by T4. Cancel out T4, we get a 2 to the power 4. That is also force multiplier. You know that force multiplier. Okay, because the mechanical advantage equal to 4. Okay, so clear. Now what is the velocity ratio? Okay, so if first we goes up to down, if that is a 1 meter, if suppose let's say effort is displaced by 1 meter, okay, that is also 1 meter here, that is displaced, this pulley is a half, that pulley also 1 by half of half means 1/4, 1/4 of half here, 1/8, and 1/8 of half here. Actually this half is goes over, so here it is 1, so 8 is plus 1 by 16. So final load is upward if effort is moved here from 1 meter and load moves 1/16 of 1 meter. Okay, so displacement of effort is 1 meter and displacement load is 1 over 16 meter, because we know that from previous case when pulleys move, when pulley is move, okay, is like that is here is pulleys move here, if displacement move in displacement effort is move 1 meter, so displacement of load, that pulley also same, that move is half of that effort, half meter is 1 unit, that is a half unit, half of the load displaced. So that is a displacement of effort is equal to 2 times displacement of load. So displacement of load, that is equal to displacement of effort by 2, actually half 1. So here half times half times half, here is a 1, half, again half, 1/4, again half of 1/4 is 1/8, half of 1/8 is 1/16. So here the velocity ratio equal to 1 by 1 by 16, displacement of effort by displacement of the load, so that is 16. So we get that is 2 to the power 4. So you see that is a 4 movable pulley here. Okay, that is a 4 movable pulley and 1 fixed. Okay, so 4 movable pulleys, 1 fixed. So mechanical advantage, there is trick, that is a mechanical advantage equal to 2 into 2 to the power number of movable pulley, and velocity ratio also the same, 2 to the power number of movable pulley. Okay, so that is, if that is a n number of pulley here movable, so that is 2 to the power n, that is also a velocity ratio 2 to the power n, and efficiency also 100%. Yes, okay. Efficiency always 100%. Okay, this is an ideal situation, that is actually a ideal, means that is a no loss here. Okay, okay, next discuss block and tackle system. Okay, there's a block and tackle system. Discuss block and tackle system. Block and tackle system. So what is a block and tackle system? First we draw a diagram. There is a two block, that is a fixed rigid support here. Okay, that is a two block of pulleys. So suppose that is a pulley, one pulley, and that is another pulley. And here also that choose diagram another pulley also. That is a three pulley. That three pulley are that fixed here. Okay, fixed support, three pulley are the fixed. That is a block one. That is a block one. And there is another block, that block one is a fixed. That block one is a fixed. Okay, that is block one is fixed. And here is another block, is block two. That block two is movable. That block two is also here. That block two is movable. Okay, and its load also connected to here from block two. Now is a tackle or connected to thread. There is a two way to connect a thread here. Okay, so either there is a connector passing through that rope, or there is a hook here. Okay, so first we draw a diagram, a hook here. Suppose that is a hook. So rope is now connected from like this, is starting from hook to that pulley. One, rope. That is a free end. Actually, first we try to draw a clean diagram. Okay, that clean diagram must be try to draw a neat and that is a free end. Okay, so one rope. Okay, that is ignore that part, that is a one single part. Okay, there's a one rope, there's a hook and connected to it. Okay, 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 now try to calculate at mechanical advantage velocity ratio. That is a block and tackle system. Here the one block, upper block is a fixed block and lower block is a movable block. And there is a note, some key note here. Upper block, block and tackle system, upper block, number of pulley in upper block, number of pulley in upper block is either equal to equal number of pulley in lower block or greater than uh, lower block. Okay, now that is a very important point. Okay, when you try to draw a system, block and tackle system, or design that system, so always we try to draw the upper block, number of pulley in upper block is always greater than the greater than or equal to the lower block pulley. Okay, so here there's a one thread or one rope, so that is means load goes down to the T, the tension or in upward direction 2, 3, 4, 5. Okay, and here the tension also here, and some person applied effort here, pull. So here apply Newton third law. Okay, block and tackle system, Newton third law. Here we get the load equal to just T same 2, 3, 4, 5 and T are same because the one rope is connected here. Okay, that is 1, 2, 3, 4, 5. That is a 5T. 5, and here we apply Newton third law. Here we get a T equal to E. So mechanical advantage equal to load 5T by T. We get only 5. Okay, and when what is the velocity ratio? Okay, velocity ratio VR. So if VR also the here that is a 5. Okay, if that is the important point how to calculate VR. If that is a 1 meter displace here, okay, 1 meter, that is there is a 5 times of tension here, or there is a 5 pulley here. Okay, so that's why load is a 1/5 meter goes upward. If 1 meter here, that is a 1/5 meter. So displacement of velocity 1 meter, that is a 1/5 means 1 by 5, that is equal to 5. Okay, so that is the same. We know that efficiency that is also 5. So efficiency also 100% because the velocity is a mechanical advantage always same number. So here we see that that is an important point. That is a mechanical advantage equal to number of 5 because there is a number of 5 pulleys here. That is equal to depend on the total number of pulleys. Total number of pulleys. Here velocity ratio also equal to total number of pulleys. If n pulley, here also the n. Okay, so that is easy. We say that that is a efficiency 100%. That is also a force multiplier. The system is because why force multiplier? Because mechanical advantage is greater than 1. Very easy. Okay, that is very easy, and also the efficiency is 100%. Okay, and here you always, that is an important note here, always ignore the weight of the pulley here. Okay, that is a we always ignore here. Okay, that is ignore friction, and that's all, that part we ignore here. That system is called block and tackle system. There is a two block here, upper block, and that is a lower block. Okay, uh, lower block, and if move upward, if lower block is a movable, upper block is a fixed. Okay, in board exam, that's important. Try to draw a diagram, draw a diagram of block and tackle system. If four pulleys, if I draw a four pulleys, how to look like this? I draw a four pulley. Four pulley means divided two parts, two plus two, two upper block, two lower block. Here that is a pulley. These two are the upper block and these two are the lower block here. Upper block is fixed support here to fix support, and lower block fixed here. A load connected to lower block. Okay, that is a rope. Okay, the rope is that is also connected from, that is also a hook here. If the starting from here, rope. That is free end. Okay, so very easy you calculate here. That is because 1 2 3 4 T tension are same because one rope is connected. Okay, so T here, effort in that direction. Okay, so that it means load equal to 1 2 3 4 Newton third law apply here, that is a 4T, and here we apply Newton third law, T equal to effort. So mechanical advantage equal to that is a 4T by T, that is a 4, number of pulleys 4 here. Okay, and what is the velocity ratio? We say that that is 1, and here it is 1/4 of change, 1/4. So if 1 meter displace here, that is 1/4 displace here, that is a 4. Same, mechanical advantage always greater than 1. So that's why not actually mechanical advantage equal to 4 means greater than 1 means force multiplier. Force multiplier. Okay, clear? And similarly, the efficiency, you know that if MAR VR is equal, that is 100% efficient. Okay, very easy. Now, here also ignore that weight of the pulleys here. Okay, that's ignore that part. Now, what is the effect of weight of pulley on MAVR? If I added to weight here, okay, and if we added to weight here, effect of weight of pulleys. First we ignore weight. Okay, now if a weight is added a pulley on MA and VR, on MA and VR, what is the relation here? Suppose that is a n number pulley. Suppose that is a n number pulley. Block and tackle total number of pulleys n. Total n number of pulleys. Okay, so if W be the lower block, weight of lower block, because the upper block is fixed. Okay, the upper block weight is hanging here, weight here. Okay, lower block is important, put is added to load here, upper block is fixed. Okay, so that is the lower block uh, weight to put a lower block here. Upper block weight is simply ignored due to that is upper block is fixed, so weight also replaced by weight also ignored here, upper block, that's why they are fixed. Lower block is not ignored because lower block is weight is also added to the load. Okay, so effort is equal to, know that that is also equal to tension T. Okay, in that any case, and what is the uh, load? Okay, this load equal to, that is load plus lower block weight, that is equal to number of pulleys into tension. Okay, so that is a number of pulley into tension, that is a 4 tension means 4 into number of pulley into tension, that is a 4 pulley, 4 into T. Here is the 5 pulley, that is also equal to n number of pulleys nt. Here also the nt here. Okay, so that's why finally put a nt. Okay, so load equal to, we get nt minus w. Okay, and what is no t equal to e here, so n e minus w. So what is the mechanical advantage here? Load by effort. Load means n e number of pulley in times effort minus weight of lower block by e. So that is n e by e minus w by e, cancel each other, so n minus w by e, that is mechanical advantage. So here in that case, so mechanical advantage is always the ideal value of n. Here the mechanical advantage is always less than ideal n. What value of less? That is w by e. W by e is less. So here is the velocity ratio n number of pulley, here n. Okay, actual mechanical advantage here. So that is the total number of pulleys. Okay, so that is that ignore. What is the less part here? Okay. Now, so what is the velocity ratio? Velocity ratio also equal to n. So velocity, if you a mechanical advantage and velocity ratio are the same, so you know that a velocity ratio is also n. And what is the efficiency? Now the important part of the efficiency is eta, that is equal to ma by vr, and ma equal to n minus w by e, and vr also n. So n by n w by e, okay, times n. So n cancel, so 1 minus w by e times n. So you see that efficiency will not 100%. Efficiency always here we see that efficiency is less than 100%, also less than the ideal values. Okay, efficiency is less 100% than 100% than 100%. What value of less is this value of less? W by e times n. Okay, so means greater efficiency. What value of less is? The value of less is w by e times n. So see that if we w is very light, w is very light. If we choose very light weight lower block pulley, so we get more efficient. Okay, so we choose a lower block pulley always as light as possible. Okay, so that's why you put a lubricant here. Okay, the lubricant grease, lubricant. Okay, you put a. That's why you put lubricant in axle. Okay, because axle are bearing position. Okay, so that's why W is less, so that is more efficient. Okay, actually 100% is not possible because that is a friction always present here. So some weight also here. Okay, how much light is not equal to zero. Okay, that is a some value are present here. So that's why not 100%. Try to put a approx 200 to tens to 100. Okay, not 100 but tens to 100. That's much as possible. Okay, so today I end the class here. If any doubt in that section, put in comment section. I will try to give the answer. Thank you.